Welcome back. Today, we're going to be talking about selection structure. Let's begin. An if statement is the first structure that we'll look at. A simple analogy for an if statement is a locked door and a key. If the key is the correct fit, the door can be opened, and if the key is incorrect, then entry is denied. Instead of a key, however, an if statement has a condition that must be met. For example, if x equals 5, then do something, like print the value of x. Simple enough, right? The next selection structure that we'll look at is called an if-else structure. The first part is just like I previously mentioned, an if statement, but it is chained to an else statement. An else statement does not have a condition attached to it, but is instead like a net that catches any input that does not meet that first condition. For example, let's say we're trying to see if the value of a variable is even or odd. Let's say our variable is called x. Our if statement would say, if x modulo 2 equals 0, print even. And our else would print odd. The if statement checks if the variable is even, and if it is not, it is caught by our else statement, and using the process of elimination, any number that is not even must be odd. The final selection structure is an if, else, which is the most common one that you'll use. The first catch must be an if statement, same as above. The second statement is an else if statement, which is pretty similar to an if statement, but it is chained to the first if statement. You can have as many else if statements that you need, but each one is chained to the previous catch. This means that a third else if in a chain can only be reached by the program if the conditions of the first three statements are not met. Finally, but not necessary, an else statement can be placed at the end of the chain as a catch-all. This may seem pretty straightforward, but it is easy to mess up the logic of this when writing your own program. So I'll use a following analogy. A coin sorting machine works as such. It has a bank of coins to be sorted, a little motor to shake them up and send them down the sorting line, and a little blocker at the mouth so that coins will go through in a single file line. And then a series of holes that the coins will fall through. The smallest size coin holes are at the top of the sorting line, and the largest are at the bottom. So if we send a loonie down the line, it will be too large to fit in the hole for dimes, nickels, and quarters, but it will be caught by the loonie hole and fall through. It will never reach the toonie hole because the size condition of the loonie hole has been met already. In code terms, the dime hole is the first if statement because it's the smallest size coin and needs to be first in the chain. And the toonie hole is the else statement because it's the largest size coin. And all other holes are else if statements because they're all in between. If you were to reverse the order of the holes, starting with toonies at the mouth of the sorting line and dimes at the end of the line, then every coin would be caught by the first hole since they are all smaller or equal size to the toonie. This probably seems pretty obvious when thinking about the physical machine, but when writing the code, it's easier than you might think to get confused. Let's do one more example to solidify the concept. A common task assigned by teachers is to create a selection structure that takes in a grade percentage and returns a letter grade. So, one way to do this is to create an if, else that starts at the high grades and goes to lower grades of the structure. For example, if the grade is less than or equal to 100 and the grade is greater than or equal to 80, print A. Else if grade is less than or equal to 79, and it's greater to or equal to 70, print B. Else if grade is less than or equal to 69, and the grade is greater than or equal to 60, print C, so on. The final else would be printing F. Now this was a perfectly reasonable way to accomplish the program, but it is not that efficient. Instead, we can have each catch contain only a single condition by working the other way around. For example, if the grade is less than 50, print F. Else if the grade is less than 60, print D. Or else if the grade is less than 70, print C. Else if the grade is less than 80, print B. And else is print A. Isn't that way simpler than the first version? Similar to the coin sorting problem, we know that if the grade fails the first condition, then it must be a D or greater. If it fails the second condition, then it must be a C or greater. It's important to step back and really analyze the problem so that you can find the easiest solution possible, like in the above example. Otherwise, you can waste hours trying to make some convoluted solution work instead of just finding some simple two-line way to solve your problem. That's it for this video. If you have any questions or comments, feel free to email me at edan.parker@queensu.ca. Thanks, and see you next time.